All right, cool. I've been informed that I'm now live. Um, maybe I'll give it like 2 minutes for people to rock up. Just report in if you're watching in the chat. Yep. All right, we got a report in the chat. All right, cool. Now I know the time delay. So how's everyone's day? Oh, I just realized every time I go to switch windows, you can all see that. So I'll try and do it less often. It's a bad habit. For anyone joining now, I'm just giving people a minute or two to join in before I actually get underway. Good, nice collection of people reporting in. Good to see. It's so much weirder just chilling out on stream than it is chilling out in person because normally I can be like really actively, directly trash talking with people, but instead I got this 20-second delay with you all. Maddie Rose, g'day. Sam Bloom, hello. For anyone who tuned in the last minute, we're just giving us some people some time to join in before we dive right in. G'day, Logan. Is that last one Rex? All right. Maybe I'll just give it 30 seconds more and then we'll dive right in to a very nice janky talk that I'm sure you'll all love. Alrighty, I think I'm just going to get started now. So I hope you're all ready to go. Welcome to Cloud Deployment Foundations. I've tried to be a bit illustrative with that talk title and not set your expectations too high. This is definitely going to be foundational kind of stuff. But there's a lot of scope for audience engagement with the 20-second delay in this talk. So if you have anything you want me to go more in depth on at all, or anything you're super curious about just shown on screen, please just ask me about it. I'm very open to completely derailing my planned content for this because it's mostly going to be a live demo and derail itself anyway. But first of all, who am I? So I think a lot of you already know me from UQCS Slack, or those tuning in elsewhere will probably be tuning in from somewhere where I have specifically posted this talk link. So I've been a professional developer for the last 5 years, not full-time all the way through of them. It comes out to about 3 years full-time equivalent in raw time, but I've been doing cloud-based stuff for the last 4 of them, whether or not that be just deploying applications in production or doing full scale, like all the fancy stuff. I just went to swear, so I will warn you now, if you don't like swearing, you're going to be disappointed because from now on, the censor is off and I will be very freely swearing. So expect a lot of that. But yeah, I graduated software engineering and maths, dual degree at UQ last year, and I was the UQCS president for a bunch of those years. And that bonus credit down at the bottom is just all of the UQCS Slack emojis that happen to be of me. So if you haven't seen them before, you should go check those out, except maybe not that last one. Yeah, so what to expect from this talk is a basic understanding of the fundamentals of cloud deployment and some of the core cloud concepts. Do not expect best practices or a super duper polished presentation. I didn't get a chance to do a full practice run. I was sick when I was meant to be initially doing this talk. So I haven't really had a lot of time to flesh it out. But because of that, the really big benefit is you get to control how this talk plays out. So you get to have a say in how everything runs. Yeah, without further ado, here is Cloud Deployment Foundations. Hope you all enjoy it. So if we want to deploy an application in the cloud, the very first thing we need is an actual application to deploy. And so I've kind of spun up this super janky API only like guestbook style thing, which I will show you right now. I just did it in Python. If you don't understand this actual code, don't worry about it. Essentially what it is I've got a database with a single table, the entries table, and that table has a timestamp, an author, and a message column. And then I've got a web application with one endpoint that allows 2 methods. Post will allow you to send a message from a given author, and get will allow you to see the last 10 messages. And that's the last 10 by timestamp. So the most recent one is first in the list. Yeah, and when you spin it up, it just makes sure that the database table is created and then serves the app on a provided host and port from environment variables. So just overall deployment principles, you kind of want things like your host and port to be configurable to some extent, and you're obviously going to have additional configuration. And also, anything where you want security, you don't want that hard-coded. So I've explicitly said, when we're creating the data, this line here creates a database engine, allows us to connect to the database. When you're creating your database connection, you explicitly want to not be hard-coding that. Because anything secret you want to be passing in as configuration, which allows you to use secret managers and stuff like that. Yeah, anyway, I'm just going to quickly spin up the server because I accidentally closed my terminal before, and actually show you what it looks like when it runs. You can't see me doing the terminal stuff because I'm doing it on another monitor. Anyway, localhost. Key error DB connection. Ta-da! So I've done, when I was testing this, I did 2 messages. The author for both of them is Blessed TRM, and the message for both of them starts with Yeet Gang, and Yeet Gang take 2, baby, was the second test message I did. So this is just a simple GET request. And then for a post request, let's add message, hey friends. All right, we successfully sent in a message that says from stream that says, "Hey, oh friends." Ooh, wild, done. And now if we refresh, ta-da! So now you can see that like the live application is actually a thing that's working. Yeah, so that's the first bit of context. The second bit of context is what the fuck is the cloud anyway? So when we talk about anything to do with the cloud, that specifically refers to the pooling of resources. So that means compute resources, storage resources. These days it means GPUs, which is pretty cool. Network resources, all of that. And I'm specifically being that abstract when I talk about what the cloud is, because the conventional idea of most people have of the cloud specifically refers to the public cloud, um, which is where people think like GCP and AWS, Google Compute Platform, and Amazon Web Services, where you have these big companies that have done the pooling of resources for you. But there's also the concept of a private cloud, which is when larger organizations that have a lot of functional teams within them also want to be able to use a cloud that the organization is so large that they can just spend the money on their own resources anyway. And that's when you get something called a private cloud. And private clouds are also a pretty established thing, and they have like very, very similar service offerings. It's just you have to manage the resources yourself. And um, the key value of a cloud for the end user is the user doesn't have to care about managing the resources, but in a private cloud situation, someone inside your organization does have to care. So someone inside your organization is actually managing those resources for you. But it is way more convenient for the end user. And the other thing is provisioning is available on demand, because the actual physical resources, there's always more there. So like when people say the cloud is infinite, it just means that they've got way more physical resources than you're ever going to be able to buy off them. Meta comment, it's just a unique experience being able to do this talk, but not being able to flail wildly in front of you all like I typically would. Anyway, let's get on to it. Yeah, so the rest of the slides are basically all like this. It's just going to be a header slide like this, and then live demo. So this could go completely terribly. And if you see anything you're interested in while I'm going through this stuff, please just interrupt me if you want me to go on a tangent about it, because I can. All right, let's do the fun. Welcome to the Google Cloud Platform console. Yeah, so any cloud service you use will have a console like, well, not necessarily like this. I would log into AWS and show you as well, but I don't actually have that prepared. So yeah, this is what the Google console looks like. Basically, you've got access to a whole heap of services, and you're only ever going to use a small portion of them. And what I wanted to kind of start with was the very fundamental building block that everyone is used to dealing with. Well, that everyone is used to dealing with conceptually is an actual computer. So one of the most fundamental things in any cloud platform is it's providing virtual private servers, or instances as they're more commonly known in the cloud world. And what they are is you're actually not buying, you're not renting a computer, you're renting the resources, the compute resources that are abstracted over. So whenever you're paying for an instance, you're paying for a certain amount of CPU and memory, as you'll see. I'm going to zoom in a bit for you. Certain amount of CPU and memory, as you'll see here. So I've gone to create my instance. The first thing I can do is I want my instance in Sydney, Australia, Southeast one. So most of the stuff that you'll see here is common across both AWS and GCP. I haven't used Azure, so I can't commit. Those are the three main public clouds you come into. Baidu is one in China. Alibaba Cloud is one in China. But yeah, so everything has a region, which tells you geographically where it is. And within each region, there are zones. In AWS, they're called availability zones. And basically, If someone sets off a bomb at one of these zones, they're geographically separate enough that they're fine, but they're geographically close enough that they fall within the same region. So I'm just going to pick one of these at random. And then I can choose, Max says in the chat, by the way, GCP is better. GCP is better for different things. I don't know what things AWS is better at, but I'm sure there is some. AWS has more stuff. There you go. That's what AWS is better at. Yeah, so I'm just going to go for a standard instance here. There's so many different options. If I'm really desperate, I can chuck a GPU on. I'm not going to do that because they're really expensive. Yeah, so basically what I'm going to go through here is just provision an instance and get this application running. So just scrolling through this relatively slowly. My boot disk, I want more than 10 gig of storage. I'm going to go up to 100. Operating system, there's heaps of options. All of this stuff is super duper common across both cloud, well, across all the cloud platforms. You can do your own custom images. You can take a snapshot of a disk and start with that, or you can have an existing disk that you detach from an instance. I'm just going to go with all of the defaults because it's easy and I'm happy with Debian. By default, the firewall is secured. So like nothing can come in. But for the sake of this demo, I'm going to let you all hit the live endpoint as I go. So please don't send anything awful. I think we can safely say the UQCS code of conduct applies to any submissions to this guest book. So don't be an arsehole. Yeah, and then there's heaps of other stuff. Security, you can turn on security features. I can add more disks. I can configure the networking. I'm not going to go over everything. I'm just clicking through stuff so you can kind of see. I'm not going to go over preemptibility. Does changing the size in gigabytes change the price? Yes, disks cost more. You're getting more stuff, so you're paying more money. But everything is like fairly linear scaling until you hit like massive, massive amounts. Although massive is very subjective. Anyway, creating this instance. I guess I'm calling it instance 1 because I forgot to set a name. It's pretty quick. Yeah, we've got the IP. Jenna, how do you send stuff? What do you mean by stuff? What do you mean by send? Can I connect to my brand new instance? Oh no. I tested this 3 times. No. Oh, this better work. While you're all waiting, here's the app repo in the chat. Oh, you'll be able to send stuff once it's actually deployed. I haven't deployed anything yet. All right, look, we got an instance. I just did that. We got a cloud computer. I can do stuff on it. Anyway, so going back to the code, I've got this setup script here. And so there's some things I know I'm going to need. I know I need a database, and I'm going to use Postgres because I like Postgres. And then Nginx and Python. I need Python 3 because it's a Python application. And Nginx, I'll come to in a bit. I'm just installing it now because I can. May as well install it all at once. Anyway, the next bit of the setup is to create a user, which is in Postgres, user and role are interchangeable. And I want to create a database called demo. Ta-da, I've created a role in a database. I would like to reiterate, this isn't best practices. This isn't like the best guide for how to do things. When it comes to, all right, well, don't worry, we'll get there. and then I'm not going to use that stuff. Install Git. And you'll notice that the instance internet connection is way better than your home internet connection because it downloads 84 meg like nothing. Oh, oops. I can't git clone. All right, we got our application here. We got Python 3 installed. I want to install pip. This is just my preferred way of installing pip. The Python packaging authority provides a script get pip.py. So what you're seeing here is just years of pain doing exactly this a couple of times. All right, we got pip. So to make my application work, what I actually need is SQL Alchemy, Flask, and Waitress. So I'm just going to install those. And also a thing called Supervisor. All right, we got an application. Which Python version is this? We got an application. Never mind. What I said earlier about security rings true. What I'm typing in here is setting the environment variable for the DB connection string for the application. And when I tested, I used SQLite, which comes pre-installed. So I need to remember Cyclopedia. And I need to install the Postgres drivers. And then I can install the pre-compiled binary version of Post. I'm sorry, did tell you it's a live demo. This could be going worse. Cool. We got it. We got an application. Okay, so if you all want, you can now go to this external IP here and you can post stuff if you want. Can I zoom in on post? Yeah, I can. All right, let's try it. Oh, it's not 8080. Not allowed. What have I done? Oh, it is 8080. Yes, there are cops in the background. Someone's broke the COC already, even though I can't actually get my application to work. All right, cool. All right. So because I am smart, I also did allowing the port to be configured by environment variables. I already posted the IP in chat, Jenna. Capital E? All right, now you can all hit the IP and do the things. Ta-da! No, that didn't work. All right, try now. Try and hit the IP now, friends. You can post stuff. I'll post more stuff. I added more myself. All right, I'm going to assume no one else is posting, so it is what it is. Yeah, more TRM messages. Anyway, yeah, so we get an application there, right? That's the very first thing. That was not at all the best way to deploy it, as you saw. I'm literally just running the application directly in the code. So the first thing we want to do is make sure that it runs itself and it stays running it if the server restarts. So there's a couple of ways to do that, and I kind of wanted to introduce you to two of them. One of them is using what's called an init system, which is something provided by your OS that spins up all the processes at startup and usually provides a service interface. So on Linux, that's usually system v init or system D. And the one I'm going to show you is system D. The other thing I wanted to show you is using a different application that will manage your processes for you. And so the way that I'm going to show you both of them is by using a different application to manage your processes for you, one called Supervisor, which is actually what we use on the current UQCS server. But then make sure Supervisor starts up normally using systemd init. Tom from the future, cloud was a mistake. Thank you, whoever posted that, because that was not me. So the point is, this is a live demo and someone else sent this message. You can all keep playing with that if you want. Anyway, Max, I only just saw your can you crank the text size a bit. So sorry about that. It's just me failing to install stuff for a while. But you can see the attempted setup steps in the setup script and also where I failed. So I need to tell Postgres I want my user to actually be able to log in. All right, before I do that, I'm actually going to go over to Nginx. So what Nginx is it's a web server. We're serving the application on the web already. Clearly it was working. And so like, why do we need to do that? The actual reason for that is generally your application web servers are going to have some kind of constraint about them. So in a language like Python, which isn't super duper fast or super duper memory efficient or doesn't have super great support for threads, it's going to be very common for you to have requests queuing up and even dropped. But putting something like Nginx in front, Nginx is super high performance and it'll actually accept the very beginning of the request for you and then pass it on. So I'm just going to show you my Nginx config here. And literally all it says is I've got my app, which is upstream, so up the chain from Nginx. And it's a server at localhost :8080, which is where I'll be running it. And then the actual server that Nginx provides should listen on port 80 and proxy pass the request on to our app. So I'm just going to copy that config as a super user, Nginx. Yeah, so Nginx has these two concepts by default of sites available and sites enabled. What you're meant to do is copy into sites available and then do a symbolic link. Oh no, the problem with symbolic links is everyone always forgets the way around they're meant to be, which is why I have this setup file. you do a symbolic link, which keeps the file in the original location, but anytime you try and edit it, it puts it in the new location. I'm not using them for this anymore. So by default, you can see there's this default site. Nginx actually gives you all of this config by default, so you can go look at stuff. So you can, like, it's worth getting to grips with all of this if you ever need to use Nginx yourself. But the very simple way to do it is just this kind of thing down the bottom. For try files, what it does is it just tries all the files in this directory instead. But what we're going to do is just remove the default because it's also trying to serve on port 80 and start Nginx back up with the new config. That's a worry. Oh, I've broken it already. Live demo gang. Cool, let's just do this. That should work. I'm editing a file owned by root. All right, so the reason for that one is the Nginx config starts in nginx.conf, and then it at the bottom includes all the other stuff. And I had a HTTP block in mind, but it includes it all inside a HTTP block. Yeah, I love the sad live demo noises. Anyway, we got our server running now. Let's go back to where we were, into our application, and run it again. Ah, but now we want port 80. So now you can see I'm serving on port 8080 again. But this time I've got Nginx on port 80, so it will again work. So this is still working, but now if we go So I'd like to reiterate at this point that all of the code for this is on GitHub. So if you're lost for the references after this, it's all there. But yeah. So I can go look at the Nginx access logs. And you'll see, you'll see I've got my GET request from my browser right here. And if I do another one, I'm going to do that in a separate window so you can all see the thing come through now. I just refreshed, and I just refreshed again, and we got stuff coming through. Someone just posted, the audience, why use Nginx over load balancers? Whoever said that, I'm getting there. Because, all right. So now I can finally move on to, now I've got Nginx set up, I can finally move on to the next step, which is like, now we get to, why do we use something like the cloud over just like having a server? And one of the first reasons for that is this concept of managed services. So managed services are one of the like major things that makes clouds super good. You saw how much hassle we had to go to get a DB set up, get the application running, and get Nginx running. If we wanted to do anything serious about like database security or performance tuning or automated backups or live updating, that would be such a hassle to manually implement. Um, but the good part is with the cloud, we don't actually have to do that. So Google has Cloud SQL. Amazon has relational database services. And what we can do is we can just like go click the give me a database buttons. And suddenly we're going to be spinning up an actual proper database that we can straight up use. So I'm going to call that UQCS demo. And then I'm going to copy that one, but not show you all. Oh no, my computer just froze. And I've lost the one text. And that didn't actually copy. All right, I got to bring it off screen. Sorry, friends. All right, I think I got it that time. Yeah, I did. Cool. And I deployed my thing in Australia to start with, so I'll just chuck it back in Australia. Don't care about configuration options. So let's do that. All right, we got a database thing up. So databases are one of the prime examples. Yeah, Jenna, you need to send an author too. Databases are one of the prime examples of managed services, but there's also like heaps and heaps of other stuff. So what do we got? We got AI platform, which has hosted Jupyter notebooks and a bunch of other stuff. Data fusion is like ETL drag and drop pipeline thingy. PubSub is managed PubSub, so it replaces message queues in some use cases. It's got source repositories for you. It's got a build service for you, so you don't actually need to set up a full CI thing. You can just use GCP. Managed services are like the bread and butter of getting people onto cloud because there's just so much less overhead to making sure they're managed. For instance, you can get things to scale up for you, like do all of that, and you don't actually need to worry about managing it all. So yeah, the instance is still being created, and we can still go on. But I realized that in the last bit, I missed the part about keeping my service running. Yeah, so we don't care about the logs there. My thing never showed up in chat. I don't know what we're talking about there, so I'm just gonna not pay attention and go back to the still running. Cool. All right, change it to application. So systemctl is the init system that's used on Debian and Ubuntu. Sorry, systemd is the init system that's used on Debian and Ubuntu right now. And that just, like I said earlier, it spins up all your stuff at the very beginning. But the way you configure it is through these service files. Oh, I can't even type. So this is what a service file, well, it's a unit file for a service. This is what a unit file looks like. You have a description and documentation. After says things you need to wait for. Install allows you to say things that require this. So multi-user.target is the default systemd target that says like, oh, I want this ready by the time users can log in, basically. And we just tell it how to start, how to stop, and how to reload. We only need to provide exec start. And because supervisor D, the command will actually fork a separate process and run it in the background, we just say type equals forking, and it'll automatically work it out. So I'm going to copy some commands over from my setup script, which are documented in the actual systemd docs, sorry, system supervisor D docs. Make sudo live demo gang. Okay. Thought I did that bit, but apparently not. The next bit I want to do is I want to tell supervisor where to find the content that I care about. So I'm going to put my own supervisor configuration file there. All right. And this is what a supervisor configuration file looks like. So supervisor, you can just specify the directory, the command, and the environment variables that you care about. So like I said, this is how UQCS does it. We have one of these for each service. So UQCS bought the shirts website, the join website. Most of the other stuff has been moved onto GitHub pages now. So there's that. Oh, there's live chat instead of top chat. Thank you. Thank you, Scott. Oh, I think it looks exactly the same for me, but thank you anyway. Yeah, so this config file is relatively simple, and this comes straight from the supervisor docs. And I'm literally just showing you these things because I can at this point. So I'm going to copy supervisor.conf as a super user to /serve/application.conf. And I'm also going to copy the application itself to /serve application.py. So you can see that I've said Python 3 serve application.py with the environment variable specified there. Sudo system ctl. That tells systemctl to reload its config. And now I can check that it started supervisor D, if I can type correctly. Oh, forgot to copy the config over. That would be a good start. This is the default systemd config path. Reload. Start. Oh, and I didn't change the name here, so. Live demo gang. Cool, all right, that didn't really work. So I'm just gonna run supervisor D myself. This means it'll be broken on restart, but cool. Oh, that didn't work. All right, let's pretend that did work. Let's hit that magical scale button. Yeah, so we've seen instances, but let's say that we have run out of compute power on our instance, even once we've separated the DV out into our managed service, and we want more compute power. So there's two main ways we can do that. There's horizontal scaling, and then there's vertical scaling. So what vertical scaling refers to is taking our instance and giving it more resources. So I don't think this is going to work. And I'm correct, it doesn't work. So we can't just hit a magic scale button and get our instance bigger. But what we can do is if we really wanted, we could stop our instance running We could detach the disk that has the operating system and our application and all the configuration that makes it work. And then we could create a new instance the same way we did before. But when we go to specify what disk we're using, we can attach the old disk that we've already fully configured. So like here, we go to boot disk and we change to existing disks. So I'm not going to detach that. That's vertical scaling. That's increasing the capacity a given resource has. Increasing disk capacity is one of the easiest things to do because we can always add an additional disk. But the other concept is horizontal scaling. So horizontal scaling is where we just go create new instance. And so what we can do here is rather than detaching the disk from this existing one, we can just go new machine image. And this will turn that disk into a new starting point for our image. Sorry, a new starting point for any further machines that we spin up. Google Managed Key. Yeah, whatever. I'm just picking random settings because they're easy. So when we create an image, what we can then do is, all right, we've got an image. Now let's make a template for any instances we're spinning up. And we want it to use the custom image we just created. All right, it's taking its time. But yeah, we can create this custom instance template. And you'll see that this is exactly the same as going and creating an instance normally. So let's create this template, even though it's not using the image because it's just an illustrative example. But this instance template will let us spin up that existing instance that if this weren't a live demo, we would have fully configured correctly the first time around so that everything's perfect. And that would, if we destroyed it, we would be able to recreate it straight away. Now that's one of another fundamental concept of the cloud, that ability to destroy things and recreate them. There's this term, treat your instances like cattle, not pets. So if something goes wrong in any situation, you want to be able to completely wipe out your entire cloud footprint and spin it back up, except for your backups and your important production data. And the reason for that is because you will have instances regularly fail. Like this is a common thing. Just as your hard drives fail in real life, your instances will sometimes fail. So relying on one to be perfectly uninterruptible forever is never going to be a great idea. All right, we've created our instance template. Now what we can do is we can create an instance group. So this allows us to create a whole bunch of other instances from that template. And we can just go auto scale. So when I say hit the magical scale button, that's what I mean by auto scale. So auto scaling allows you to, using metrics, automatically just add more instances as soon as things get tough. So by default, they give you CPU utilization, but you can also connect a load balancer once you've got an instance group. And that'll allow you to take that role of Nginx that I had before. Instead of having an upstream that passes to it, you can make that a managed service as well. And you can use a load balancer. And so you've got this automatic scaling group of instances. You've got something that handles your connections when you have too much load. And then combining the two, you get this ability to just magically scale up perfectly. And when I say perfectly, I mean not at all perfectly. It's very easy to run out of capacity in real life production systems. When you get, if you're a large enough organization, when you get a 30% traffic spike, that could be 1,000 new instances. But yeah, so by default, they provide CPU utilization as a metric. So if your compute's going really hard, you can get it to automatically scale up. And monitoring is another managed service. So you can pick a really detailed monitoring metric or do a custom monitoring metric to auto scale on. Or you can turn it to turn off auto scaling. And then you can use the API to manually scale it. Yeah, so super duper flexible. Size of instance group won't change. Yeah. Yeah. And we can create our instance group and we'll change it to CPU. Make it real low. Yeah, that's the magical scale button. You start with your VM instance, you create a way to repeatedly spin it up, like an instance template, and then you can have auto scaling. And then once you've done that, you chuck your load balancer on and you use that to replace Nginx. So there's no harm in still having Nginx on the server, but now you can do a connection that allows people going in to load balance across your things. Backend services. Create a backend service. Oh, I need a bucket. Buckets need to be globally unique. Because it's made me get into that stuff, let's talk about buckets. So that's the magic scale button. Now we get to the stuff I couldn't work out how to fit into this format section, by the way. So if you're, like it says, any service anyone is curious about in the sidewire, we're going to talk about networking, cloud storage, and logging now. Yeah, so first up, cloud storage. Every cloud platform has a very fundamental building block of a cloud storage service. So Google Compute Platform has Google Cloud Storage, AWS has S3, Azure has Azure Blob Storage, and all they are is it's a collection of buckets and then keys mapping to files. So in that sense, it's a key value store, but everyone kind of treats them like an abstract, cloudy file system type of thing. TRM bad UQCS demo. Cool. Store it in Azure, I don't care. Great. All of these things cost money, by the way, but I just am lucky to have credits right now. Oh, I accidentally hit backend bucket before. That was unintentional. All right, well, we got our instance group. Port 80. Yeah, it's when you're actually doing this for real, it's worth like having a read of all of these things. And create a health check. Protocol, HTTP, request path. Yes, get, perfect. Port 80. So now I also don't have to consider setting up HTTPS because the cloud does manage HTTPS for me. Create Google Managed Certificate. See, like I'm not actually going to do that because I don't want to create a certificate. But Google will automatically do one for you if you do it. Actually, I have that domain. That's good enough. Done. We got HTTPS and everything. But I'm also going to serve it over HTTP normally. I can create a static IP address. How far anyway? All right, we're a full 53 minutes in. I'm going to leave some scope for Finster to do his ideally more polished talk next time. And I think he was probably going to talk about the networking model and securing it a bit more and about monitoring. So for now, what I'm just going to do is slowly scroll down the sidebar and see if anyone wants to talk about any of these things. IAM stands for Identity and Access Management. Magic security stuff. Don't know what that is. So App Engine and Kubernetes Engine, Cloud Functions, and Cloud Run. When I talk about a managed service, it's about making you have to manage less. So we got it down to Compute Engine, you just have to manage your application running. But rather than application running, we can get it down to the point where they manage everything except for the code that you wrote, which is something like Cloud Functions or Cloud Run, depending on the use case. Alex wants IAM. I'm just going to keep scrolling down the list. The GCP equivalent of CloudFormation is don't use it. I'm not going to tell you, but use Terraform instead. So Terraform is a generic tool that goes over all of them. Anyway, more storage services that each do different things. File store is NFS. Memory store is Redis or Memcached. Data transfer is for saving money on your transfer costs by like transfer appliances. Literally, they'll send you a hard drive. Everything here does have a CLI. The CLI isn't always as fleshed out, but sometimes it's more fleshed out. This is all the networking stuff. So just call out stuff here that you're interested in, and then we'll come back to IAM. I'm leaving monitoring stuff for Finsta, but the point is all of these are managed for you. Identity platform is like users and login. Container registry is for containers. Cloud builder I mentioned before. Yeah, the power of the cloud, managed services. Anyway, one of the things that is, by the way, feel free to leave here at any point now because this is just me talking about stuff. Yes, Max, Spanner is insanely cool. I'm going to talk about it later just because you brought it up. Identity and access management is anyone who has access to your GCP. GCP has projects, AWS has accounts. Anyone who has access to it has a set of permissions attributed to them. And so you've got to manage logging into stuff and then also what people can access. So you can start with, where are we? Yeah, you've got members and roles. You can add a member with given roles, and the roles are just collections of permission stuff. And basically, you can go down to the level of, I want to give someone permission only to create instances. So this is like more detailed than that. I want to give someone the permission to manage compute engine instances. And it's going to be a new member, and I'm going to make it like also me. Except it's not going to like that because I'm already a member. Yeah, so I just gave myself compute instance admin permissions, which I already had because I own the GCP project. But if I want, I can create my own roles with like insanely granular permissions that allow me to only create instances with a given specific prefix of a name. So I'm going to go back to compute engine admin. Compute instance admin. Yeah, cool. So this shows the list of all of the permissions that a compute instance admin gets. Compute instance group. All right, we want to be able to see the instances and create one, and that is all. And so now I've made my only create role. So the concept of identity and access management with these super granular permissions is something that's common to both AWS and GCP. And I'm assuming it's common to every other thing. Like I mentioned before, I've only really used those two. But for any serious enterprise organization, managing your IAM is one of the biggest challenges. And also learning to use IAM policies in depth is a hugely complex field that requires a bunch of research for every single service you interact with. So it's not something I'd possibly cover in any depth, but hopefully that's a sufficient overview for you. Next up on the list of stuff that is cool is Spanner. Spanner is nuts. It's so fucking sick. So Spanner is, when they say globally consistent scalable relational database, they mean globally consistent scalable relational database. There's this problem in distributed systems where things can't be consistent, fully available, or network partition tolerant. And that's like mathematically provable for specific definitions of those terms. But one of the more fundamental problems that makes that difficult is clock synchronization. So like you want things to be able to, like if you can check a timestamp on a transaction so you know what order they were done in. So if you've got some way of ordering transactions and you can reconcile the end data based on that, then you can kind of get away with a lot of stuff. But synchronizing clocks is such a ridiculously difficult challenge, and you need this really high accuracy to be confident in any transaction ordering based on time. And so what Google did is they just added clocks. Like it wasn't GPS clocks. They added atomic clocks to their data centers so that every single thing for Spanner is consistent to within, I think it's like 11 milliseconds. So your timestamps are like super duper consistent across the globe, and it makes one of those problems just effectively go away. So it's just such a big brain approach to consistency, but you get this SQL database with wild consistency just because Google's like, all right, fuck it, let's chuck some atomic clocks in our data center, which is just a really cool, innovative way to solve that kind of problem, which I'm very in favor of. Um, so yeah, stuff I couldn't fit in, and I think anyone was curious about, but also questions and mocking me. That's where we're at right now, that point of the evening. So if anyone's keen to see anything or to mock me to make me go fix up something that I stuffed up in the intro bit, now is your time, and I'll patiently await the 20-second delay. Oh, someone specifically asked for Let's Encrypt. Just ignore Let's Encrypt and use the cloud managed certificates. Everything has it. If you do want Let's Encrypt, their docs are pretty good now. I'm still giving you time for anyone to harass me or mock me. There was a question in the server I deployed. Why use Nginx over load balancers? You don't. They serve different purposes. Oh, there was a CloudFormation one. Oh, okay, I actually got it. What is GCP? So I answered the GCP Azure equivalent of CloudFormation briefly, but I'll elaborate a bit. So there's this concept of infrastructure as code, blacklisted from Mongrel due to overconsumption of hot source. I love it. Erlang greater than Haskell, also Scala greater than Haskell. I wrote name as a field instead of author and kept wondering why it was bouncing. You what? Okay. Cool. Are you guys loving the live demo? I hope so. All right. So yeah, CloudFormation. There's this concept of infrastructure as code. When it comes to provisioning your infrastructure, setting everything up, you want to be able to do it in a replicatable way. So before I mentioned the cattle not sheep, sorry, the cattle not pets thing, this is kind of the same, but rather than just for an individual server you manage, it's your entire cloud architecture. So like your networking configuration, your instance templates and instance groups from scratch, all of your IAM stuff as well, so managing users and permissions, security settings, firewall settings, managed services, just everything. If you have code that can automatically regenerate that, then there's absolutely no problem if someone clicks the delete button accidentally. So that's what CloudFormation provides. AWS gives you CloudFormation as a language to kind of configure that automatic rebuilding of your infrastructure. And it also makes changing it a bit easier as well, because you have this version controlled history of how your infrastructure changes. And someone was asking, what is the GCP/Azure equivalent of CloudFormation? For GCP, there is one. Don't use it. It doesn't cover nearly as much. What you want to use instead is a service called Terraform from HashiCorp. Terraform is lit. It's sick. I love it. Terraform doesn't just do those. It does all of this other stuff as well, but it can also do all of them at once and have interdependencies between them all. Very cool. Yeah, Terraform's sick. In fact, a lot of people even recommend using Terraform for AWS because it is very well supported, just because people don't like CloudFormation. I also don't like CloudFormation, but when I'm writing CloudFormation, I use this thing called Troposphere, which is a Python package for generating it. And AWS has CDK, which does CloudFormation-y stuff as well. Yeah. There was the old question about Nginx versus load balancers. Yeah, so Nginx is a super performant web server written in C, and it's very configurable, and you can do a whole heap of stuff. But the main reason you'd want to use it is like it's super duper configurable and fast. So if you need to do things like really like niche filtering rules, or the main thing I use it for is running multiple services on the same server when I'm treating it like a pet, so not cloud style. Running multiple services on the same server and then redirecting to different ones depending on the actual URL that the request is done with. But even if you're running a production application that doesn't need that, I do recommend putting it in front of, for example, your Python server, because it can just hold the request in a request queue for you. And it manages that kind of thing a lot more nicely than Python does. And also, because it manages it more nicely than Python does, if your Python server stuffs up and times out, you can get Nginx to report back to your user, hey, the Python bit's timed out. But because Nginx itself has so much more capacity for processing requests, because it is like so fast and just fucking awesome, you can get a bit better user feedback in the end. Load balancers provide some of the same stuff, so it'll like hold your requests for you and pass them on. But the main reason you want to use them is actually to balance your load. You can use Nginx as a load balancer, but when you're in the cloud, why would you want to like physically manage a load balancer unless you're also using additional Nginx features? So again, it's just using managed services when you don't need some specific super niche detail. Someone asked weather tomorrow. Oh, my keyboard's stuffed up. There we go. There you go. That's the weather tomorrow. All right. Any last questions? Oh, how does Docker and Kubernetes fit in with all this cloud business? So Docker is just awesome. I've lost the GCP. Docker is just awesome. I kind of didn't touch on Docker at all. You'll see that Unicode handling doesn't work. What? The JSON encoder must not work. Oh, it's because of the MIME type it returns. I think. Oh, someone sent in their attempt at Unicode, but their backslashes didn't work correctly. So it's actually just a backslash, because Python does have full Unicode support. Yeah, how does Docker and Kubernetes fit in? So Docker has this concept of images and containers. So an image would directly replace that image that we created of this VM, except Docker at the abstraction level is not like a full disk image. It's just the OS part on top of the kernel. So there's less resources involved in running a Docker container than there is in running a full operating system. And that also lets you pack multiple containers, which are effectively like mini VMs, into a single machine. So if you want to run a lot of stuff on a single machine, but you want it to be conceptually separated and look inside the container like separate OSs, that's what Docker's great at. And what Kubernetes does is it makes it possible to manage Docker workloads on a whole bunch of machines at once. And when I say manage, I mean like really cool shit like blue-green deployments, auto scaling, not just the number of machines, but also the number of processes per machine based on the workload. And you can scale different types of containers independently on the same type of machine based on resource requirements. It will, if you have a whole bunch of stuff you want to run and it won't run neatly on a single machine, but you don't want to like do the hard work to think of optimal packing it on multiple machines, you can just throw it all at Kubernetes and get it to do the hard work that way. If you lose a machine, Kubernetes will automatically migrate your workloads across for you. It basically just any problem that you'd want to manage if you are deploying applications yourself, Kubernetes has some way of helping you do that easier. And that's all built on top of Docker. But what Docker just gives you is mini VMs. Yeah, that's the short of it. I'll go till 6:15, so get in your last questions now. But if no one has any questions in like the next 2 minutes, we'll leave it there. I'm going to start wrapping up, but if questions come in, like, I'll take them. Anyway, yeah, I hope you guys all enjoyed Live Demo Gang. Yeah, it's obviously not the most polished talk I've done. We covered a lot of content, so don't be surprised if stuff goes in one ear out the other. But kind of the things that I did want to hit on are managed services, number one, because that is like the core reason that the cloud got so popular is it just stops you having to care about things. Instances stop you having to care about physical resources. Yeah, you don't have to care about how your files are stored. You just dump them in. You don't have to care about managing your SQL database. Yeah, managed services, number one. Number two is horizontal and vertical scaling and just the idea of how they happen in practice. The actual like super specifics of instance groups and instance templates don't matter. Like obviously you need to know how the instance is launched in order to scale it up. But the concept is there. And then yeah, that's really the core of it. And then other stuff is cool. Yes, there's a part two to this, and it's going to be fun for Finster to try and work out what he's going to cover in it. I think he's going to just go straight to Docker and Kubernetes because that stuff's cool and much closer to best practices. Yeah. Thanks, everyone. Thanks for sitting as I bumbled my way through this. I do appreciate the listening, and I do hope you got something valuable out of it. But yeah, thanks, everyone.
Thanks, Tom. We'd like to give you a quick virtual mug on the stream. Thanks again. Thanks everyone for coming. Hope you guys learnt something from this, and we'll see you again next time.